All right, guys, we're going to do 11.3 now, conditional probability. And conditional probability is figuring out the probability of something happens if we already know another event occurred. Okay? And by definition, these are going to be, conditional probability is going to be dependent, okay, probability, but it's a little different than what you're used to, we did before. Has already occurred. So this is supposed to be okay. And we want to do this, we want to say the probability of B given A. That's, I'm not going to write the whole thing, but you read this, the P stands for probability. Then in the parentheses, you say of. So it's the probability of this stuff in the middle. And it's the probability of B. And this line right here means given. And given means that something else has already happened. So this is the probability of B given A. And all that means is it's a probability that B will happen if we know all A has already happened. And the formula for that is the probability of B given A is the probability of A and B happening together divided by the probability of A. Okay? Now, you don't actually need to know this formula for any of these questions, okay? This actually, here's what's called Bayes' theorem. Bayes' theorem. It gets used a lot in statistics. In fact, there are two different fields of statistics. There's frequentist statistics, which is mostly what I dabble in. And then there's Bayesian statistics. And the Bayes people, they actually do all their statistical methods and calculations a completely different way from the frequentists. And both groups tend to end up at very similar answers. There are edge cases where that doesn't happen. I took an entire class on Bayes' theorem. Yes, it's basically an entire class on this formula and how complicated it gets in different situations. And it's pretty interesting stuff. Okay. So let's look at the problem. Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So here, since we're given that the card was red, okay, this isn't a very good question, but given that the card was red, what's the chance of getting a queen? Well, there are 4 queens, right? And 2 of them are black and 2 of them are red, right? If I remember correctly. I haven't played cards in a long time. We don't care about the red ones, or we don't care about the black ones. We just care about the red ones. And these red ones each come in sets of king, queen, jack, 10, 9, 8, and so on. And there are 13 of them if we include the ace at the end. Right? Yeah. Ace to 10, then jack, queen, king. So 1 out of 13 is going to be a queen, and 1 out of 13 here is going to be queen, or 2 out of 26, which is 1/13. I don't think it's a great problem because it's this. If I just said, what's the probability of drawing a queen? Well, the probability of drawing a queen is 4 out of 52, right? Because there are 52 cards in a deck. That's the same thing as 1/13. So actually, given that the card was red, doesn't affect our probability at all. There's no way I'm doing this because I'm not going to figure out all the perfect squares from 1 to 100. That just seems prohibitively difficult. But I'm going to show you a couple conditional probability problems just to give you a sample of this. There's none of this on your test. 10 of you just closed out. Just kidding. Let's look at tables. Tables are where this is really useful, okay? So there are some things that we can talk about in this table. We have 2 things. We got boys, we got girls, and we got football, and we got hockey. And I could say, first of all, how many are there all together? There's 16 plus 6 is 22, plus 10 is 32, plus 10 more is 42, plus 8 more is 50. Oops, it actually said 50 up here, so I didn't have to do that math. So there are 50 total, right? So there's some things I could say here. I could say the number of boys that, what's the probability of getting a boy who likes football? Well, that's 18 out of 50. What's the probability of a boy who likes hockey? That's 10 out of 50. What's the probability of a girl who likes football? 6 out of 50. A girl who likes hockey? 16 out of 50. And I can also say, what's the probability of getting someone who likes football? Well, I would use both of these categories. And it'd be 24 out of 50. Or I could say, what's the probability of getting someone who likes hockey? 26 out of 50. Okay, so you can combine, this table's nice, you can combine different categories and talk about what's really going on in different ways. But we can also say, what is the probability of preferring football given that we have a girl? So here's how we deal with the given, okay? If I just say, what's the probability of having a girl who likes football? That's 6 out of 50, right? That's easy, it's just 6 out of the total. But if it's given that it's a girl, what it means is we're no longer dividing by the total, we're dividing by this right here. So how many girls are there? Here's my girls. How many girls are there? There are 22. So given that it's a girl, what's the probability that I get one that likes football? 6 out of 22. So if it was probability, probably a football given girl, that's, I reduced this to 3 over 11, right? This is 3 over 11. And it's probability of football, comma, girl. If you put a comma, it means they happen together. If I get football and girl together, that's 6 out of 50. So these numbers are very different, aren't they? Probably the boy, given that it's hockey. So what if it was boy and hockey? What's the probability of getting a boy who likes hockey? Well, that's 10 out of 50, right? That's easy. Well, if it's here, it's given. It's not given that we have a boy. It's given that it's someone who likes hockey. If it's given that it's someone who likes hockey, what's the probability of getting a boy? Well, it's 10 out of, how many do I have altogether? 26. 10 plus 16. So that's 10, 26, which is, again, very different from 10 over 50, right? 1/5 is different from 5/13. So the conditional probability is looking at parts of our values in a table, or parts of conditions, or parts of probability. I might stop there. I actually don't know if there's anything else really worth going over in this. Let me look. Yeah, I don't think there's anything really worth going over here. I think this is, if you can work through these problems, 5 and 6, and you get these, you're good. And this is just the same thing. The only, yeah, it's the same thing really, just expressed in a different way. So I don't worry about these. The problem 7, okay? If you can do 5 and 6, you're good on conditional probability for the idea that I want you to just be introduced to this idea, okay? So have a good one.